Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 18 to 24, which account for 22 of these marks. Edexcel Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18. So we have 2a to 5c equals 6 to 25, 4b to 7c equals 20 to 21, and it wants us to show that a plus b to b plus c equals 17 to 20. So I'm going to take each ratio separately and simplify it a little bit more, because here I have multiples of the letters, whereas here I only want a single letter. I don't want it in terms of multiples. So if we look at this first ratio, so 2a to 5c is 6 to 25. Well, if 2a equals 6, then 1a must equal 6 divided by 2, which is 3. And if 5c is equal to 25, then c must be equal to 25 divided by 5, which is 5. I'm going to do the same with the other one. So I've got 4b to 7c, which is 20 to 21. So I'm going to make that in terms of b and c rather than multiples of them. So 20 divided by 4 is 5, and then 21 divided by 7 is 3. So now I'm dealing with these single letters. I'm going to figure out this ratio here. To do that, what we notice is I've got c in both of these. So I'm going to rewrite this as a to c to b. So in this first ratio, it's 3 to 5. And in this ratio, c to b is 3 to 5. I want this middle to be the same. I want it to be equivalent so I can combine these ratios. So I'm going to multiply this one by 3 and this one by 5. So a multiplied by 3 is 9, 5 multiplied by 3 is 15, 3 multiplied by 5 is 15, and 5 multiplied by 5 is 25. So now I can write the ratio as a to b to c. So a is 9, b is 25, and c is 15. So now we can use these values to show this ratio at the top here. So we're doing a add b to b add c, and we're trying to show that it equals to 17 to 20. So a add b, so 9 add 25, b add c, 25 add 15. 9 add 25, that's 34 to 40. And then if we divide this side by 2, that gives us 17 to 20. And we've shown that equivalency. Question 19. ABC is a right angle triangle. So we've got a right angle triangle. We know the side AB. So AB is 9.3 centimetres correct to the nearest millimetre. AC is 12.6 centimetres correct to the nearest millimetre. Calculate the lower bound for the size of the angle marked X. You must show all your working out. So because we're looking for the lower bound, we're going to need the upper and lower bound of these lengths, because this is the information we're going to use to find that angle. So if we do the upper bound of AB, so the nearest millimetre is to the nearest 0.1 centimetres. Half of that is 0.05. So for the upper bound, we do 9.3 plus 0.05. Oops. .35, and then for the lower bound of AB, we subtract 0.05. .25. So we're going to do the same for the length AC. So the upper bound of AC is going to be 12.6. Now again, it's the nearest millimetre. So 12.6 plus 0.05, which is 12.65. And then the lower bound of AC is 12.6 subtract 0.05, which is 12.55. So next thing we need to do is figure out which of these values we're going to use. So we want the lower bound of the angle marked x. So to find the angle, we'd use trigonometry. So we have the opposite and the hypotenuse. So sin x is equal to the opposite over the hypotenuse. So sin of our angle is equal to the opposite divided by the hypotenuse. Now we want sin to the -1 to find x of the opposite over the hypotenuse. So we're doing a division here. If we want the lower bound, we need to divide the smallest possible number by the biggest possible number, which will then give us our smallest possible answer. So when we substitute these in, we want the smallest possible value for the opposite, which is AB. So we're going to use the lower bound of AB, and we're going to divide it by the upper bound of AC, which is H, because the bigger the number you divide by, the smaller the answer you're going to get. So we have shift and sin, and then it's 9.25 divided by 12.65, close the bracket. So it's 46.989,21356. It doesn't tell us what to round it to. Everything else is to 1 decimal place. So we could write it to 1 decimal place, or we could just leave it like this. So 46.989, and we'll stop it there. Question 20. ORT is a triangle. ORT. OT equals A. So OT equals A. R to T. RT equals B. That's labelled on the diagram for us. M is the point on OR, so OR and M, such that OM to MR is 2 to 3. So OM to MR, 2 to 3. So there's 5 parts in total. 2 plus 3 equals 5. So O to M is 2/5 of that length, and M to R is 3/5 of that length. So it's worth noting that. Express MT in terms of AB. Give your answer in its simplest form. So we want to give a vector for the journey from M to T. To do that, we need to find out that distance here, MR. So we're going to start with O to R, because that's one that we can easily do. So going from O to R, I'm going to go along lengths that I know information about. So O to T, add T to R. So O to T is A, T to R is B, but we're going in the opposite direction to this arrow here, so it would be minus B. So O to R is A subtract B. Now I know if I want to go from M to T, what I'm going to do is go M to R and then R to T. That's the route I'm going to take. So M to R is 3/5 of OR, of this length here. So M to R is 3/5 of A subtract B, and then we would add RT, so from R to T going in the same direction as this arrow, so we would add B. So now I'm going to simplify this a little bit more. So MT equals, so this is 3A subtract 3B all over 5. All I've done is deal with that bracket. So now I'm going to write these separately. So that's 3A over 5 subtract 3B over 5, add B. So now I can collect like terms. So I can collect my B terms together. So I've got minus 3/5 B plus a whole B. So let's see. So if I've got minus 3/5 and then I'm adding a whole one, that leaves me with positive 2/5. So I have 3A over 5 plus 2B over 5. And that's my MT. You could also write it as 3/5 A plus 2/5 B. It's the same thing. And that's what I'm going to write nice and clearly on my answer line. Question 21. Here is the graph of y equals f of x. This is y equals f of x. Part A. On the grid below, draw the graph of y equals f of x, subtract 4. So this subtract 4 on the end is outside of the bracket, so it impacts the y coordinates. So because it impacts the y coordinates, it means that this graph is going to shift down 4 places. So this point here is at -3, 0. So it's going to be at -3, but it's going to go down to -4. It's going to go from 0 down 4 places. This point here is at -2, 1. So -2, 1, but then it's going to go down 4 places. 1, 2, 3, 4. And now you can see where the rest of the graph's going to form. But if you weren't entirely convinced, you could plot each of those points separately, moving them down 4 places before you then draw your graph. Okay, next one. Part B. On the grid below, draw the graph of y equals f of negative x. So this negative x is inside the brackets, but what this means is, with a negative x inside the brackets, we're going to reflect on the vertical axis. The vertical axis is this one, so we're going to reflect this graph over the y-axis. So this point here is 1, 2, 3 away, so we're going to go 1, 2, 3 away on this side. So here. And this point here is 1, 2 away, so we're going to go 1, 2 away on the other side. And then 1 away. And then at 0. So that's an invariant point because it's actually going to stay where it is. And then draw the graph. Question 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it. The replaces it is important in the box. She does this n times where n is greater than or equal to 2. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. Okay, so if we're dealing with blue pens and red pens, let's see if we can figure out the probability of a blue and the probability of a red pen. So blue pens is 4 times the number of red pens. So if red pens was 1, blue pens would be 4 because 1 times 4 is 4. So we have actually a total of 5 pens here if red was 1. So let's go with that for now. So the probability of picking a blue pen would be 4 out of 5. And the probability of picking a red pen would be 1 out of 5. So we have some probabilities here. Now what we would do here then is we would multiply the probabilities together where appropriate with a tree diagram. However, we're writing an expression in terms of n because we don't actually know how many times she does this. We just know that it's going to be greater than 2. So the probability that Rita gets a blue pen at least once and a red pen at least once is the same as 1 take away the probability that she picks all red or she picks all blue. Because any other options will be a mixture of picking red and blue pens. Okay, so the probability of picking red is 1 out of 5. And we would multiply that however many times we did this experiment, which is n. So I'm just going to pop it to the power of n because it'd be 1/5 multiplied by 1/5 multiplied by 1/5, however many times she picked pens. Okay, we don't know how many there are in total. And then I would do the same for blue. So it'd be 4/5 to the power of n. So 1 subtract this probability, subtract this probability. So the total probability of all getting all red or all blue, depending on how many times she picks these pens, would be our expression. So 1 subtract 1/5 to the power of n and 4/5 to the power of n. Question 23. Here are 3 similar triangles. So similar triangles is important. We've got ABG, ACF and ADE. ABCD and AGFE are straight lines. That's the size of the larger triangle. AB to BC to CD is equal to 1 to 2 to 3. So that the area of ABG to the area of BCFG to the area of CDEF is equal to 1 to 8 to 27. So we have a proportional relationship here with the ratio in terms of these lengths here. And then we have a proportional relationship in terms of the areas of these 3 parts of this shape. Now you'll notice ABG is the triangle, but BCFG is this smaller section here, trapezium, and CDEF is this trapezium here. So the first thing I'm going to do is I'm going to make some kind of relationship between the lengths of these sides. So I've got A to B, B to C and C to D. So A to B is 1, B to C is 2 and C to D is 3. So A to B is 1, but A to C is 1 plus 2, and then A to D is 1 plus 2 plus 3. So I've got A to B is a side of this triangle, A to C is a side of this triangle, and A to D is a side of this triangle. So I've got that proportional relationship between the sides. So that's 1 to 3 to 6. So this is lengths. We're working with area, so we're going to convert these to areas. So area of ABG is going to be this squared. Area of ACF is going to be this squared. And an area of ADE is going to be 6 squared. So this is the areas. So we have 1 to 9 to 36. So we want the area of ABG, which we know here is 1, to the area of BCFG. Now we have the area of this whole triangle ACF. BCFG, we'll find this if we take that smaller triangle away. So BCFG is ACF subtract ABG. So it's ACF triangle subtract this triangle here. And then the next part of the ratio we want is CDEF. Well, CDEF is this larger triangle subtract ACF. So we're going to do ADE subtract ACF. So ABG, we know the area is 1. ACF is 9. Subtract ABG, which is 1. ADE is 36. Subtract ACF, which is 9. So we have 1. 9 take away 1 is 8. 36 take away 9 is 27. So we've shown that the areas of these parts of the shape are in this ratio. Question 24. The diagram shows 8 identical regular octagons, 1, 2, 3, 4, 5, 6, 7, 8, joined to enclose a shaded shape. Each octagon has side lengths A, so this side is A, this side is A, and so on. Find in terms of A an expression for the area of the shaded shape. Give your answer in this form where P is an integer. Integer means a whole number. You must show all you're working out. So if I want the area of this shaded shape, the first thing I'm going to do is see if I can split it into shapes that I can deal with more easily. So if I was to draw a line here, line down here, across here, and across here, you can see that I have a square in the middle, and then I have 1, 2, 3, 4 triangles around the outside. So now I'm working out the area of a square and then the area of 4 triangles. So to work out the area of the square, I need to know, so if this is A and this is A, I need to know this length, because then it would be A plus this plus A. So if I want to know this length, I'm going to find out this angle here. It's going to make my life easier. And this angle here is formed by the exterior angles of these two octagons. So the first thing I'm going to do is I'm going to do 360 divided by 8. That tells me the size of the exterior angle of one of the octagons. And this angle here is formed by two of those exterior angles. So this then tells me that this angle here is 90 degrees. Now if I take this triangle and draw it here, we have A, and 90 degrees. I need to know this length here so I can find the length of the square to find the area of the square. I know with a right angle triangle I could use Pythagoras. So to use Pythagoras to find this length, I would do A squared plus A squared, and then I would square root it. So this is the square root of 2A squared. Now I can't square root 2 and get an integer answer, so I'm going to write that as root 2, but I can square root A squared and get an integer answer. That would leave me with A. So this length here is root 2A. So I know that the side length of the square is A plus root 2A plus A. So that's 2A plus root 2A. So if that's the side length of the square, I can now find the area of the square. So the area would be this length multiplied by itself, because all the sides of a square are the same. So let's expand these brackets. So that would give me 4A squared plus 2 root 2A squared plus 2 root 2A squared plus 2A squared. So let's simplify that. 4A squared plus 2A squared is 6A squared plus 2 root 2A squared plus 2 root 2A squared is plus 4 root 2A squared. So that's my area of the square. Now I need to find the area of these triangles so I can add those to this area to get the total area of the shaded shape. So area of a triangle. What we could do here is, so area, I'm going to use the trig formula. So it's half times the two sides, so half times A times that enclosed angle, but it's sin of the enclosed angle. So it's a half times A squared times sin 90 is 1. So the area of one triangle is a half times A squared, or A squared over 2. We have 4 of those triangles, so 4 times A squared over 2 is 4A squared over 2, which simplifies to 2A squared. So I'm now going to add these two areas together for the total area of this shaded shape. So 2A squared plus 6A squared plus 4 root 2A squared. So that gives me 8A squared plus 4 root 2A squared. Now they want it in this form where P is an integer that I've taken out as a factor. A squared is also taken out as a factor. So if I take A squared out of that bracket there, that's going to leave me with 8 plus 4 root 2 that needs to be factorised. So 8 and 4 have a common factor of 4. So if I pull out 4, 8 divided by 4 is 2. 4 root 2 divided by 4 is root 2. So if we look here, we have an integer, P, 2 plus root 2 inside the bracket, and then A squared on the outside. So the answer line to this one is on the other page. They gave us some extra working out space if we needed it. So I'm going to take that expression and write it on my answer line.